Hey guys, it's Ethan from Zimmer Labs, and this is a computer that I just finished building for Michael. It's a bit of a departure from my usual videos, but I just wanted to do a quick run-through to show Michael what's going on with everything and how I built it and what's inside. To start with, we opted for this NZXT H510 Elite case, which is really a nice case. Very simple, very easy to work with. Very clean looking. We'll take the side panel off first. And here we've got the NZXT fan and RGB LED control brain center here. And then mounted up on the side, we've got one of the 4 hard drives that's in this guy. This is a SATA Samsung solid state 860 EVO 250 gig, very small, just backup drive. There's one screw here, but then once that screw is removed, you can pop this guy right off. And then I did wire up power and another SATA connector and mounted them right here so that if Michael wants to add another SATA drive, he can just attach it here and plug it right in. Those are all powered up and ready to go. We're running 1200 watt Antec High Current Pro 80 plus gold power supply. It's a really nice power supply. And then all the extra cables are just packed into this little compartment down here. So any other cables connections that need to be made, you can just slide these guys out and plug them in wherever you need to. But for now they're in there. And then the remainder of the cables, a whole bunch more, but these are modular and we're not using them, so just left them off for now. On the back end, we've got PCI Express slots for whatever cards you want to add on, and then 2 vertical slots, or 1 really vertical slot for a video card. This is a Z390 chipset, so it's got a 10 gig network port for Ethernet, and then dual Intel gigabit Ethernet right here as well. USB 3.1 Gen 2 Type C and Type A, and then 1, 2, 3, 4, 5, 6 USB 3.1 Gen 1 ports, DisplayPort, HDMI, and built-in Wi-Fi. The board comes with this Wi-Fi antenna. You just attach to right here. On the side, this side door just pops open and swings down. There is one thumb screw you can put on there too. The motherboard is an ASRock Z390 Taichi Ultimate motherboard, which is probably the best Z390 motherboard really that was made as far as a balance between price and performance and goodies. This thing is totally straight up loaded, but at the same time wasn't, you know, a $500 or $600 motherboard. $250 to $300 motherboard, which is really a bargain for all the stuff you get. We've got right here a USB 3.1 Gen 2 header, which is a really nice option because that allows you to connect it up to your case and allows you to have really high speed USB right on the front end. Also has really high-end audio, Realtek audio in this guy with all Nichicon gold capacitors, 7.1 surround, also digital Toslink optical output for audio, and then 3 M.2 high-speed slots, which we populated all 3 of them. So these are the other 3 hard drives. We did triple ADATA SPG X8200 M.2 drives, 2 terabyte, 2 terabyte, and a 1 terabyte. The 2 terabytes are running in a RAID 0 array, so that's, the computer's going to see this as a 1 terabyte and a 4 terabyte hard drive. With the goal here being the 4 terabytes is for storage of media, pictures, whatever, and then the 1 terabyte hard drive is for the operating system and for software and stuff like that. And the point of doing that is that you get crazy outrageous speeds from using M.2 hard drives. Not only are they solid state, but in the PCI Express Plus. So this is a crazy fast computer. Next up, for RAM, we only put 2 sticks in here, but this is 64 gigs of G.Skill Ripjaws using Samsung B-Die chips. It's 3600 CL16 RAM, which is the fastest possible RAM you can get at that capacity. And you can overclock the RAM beyond 3600 megahertz, so we could turn the frequency up to 4000. Probably no problem, just give it a bump in voltage and maybe tweak the timings, but probably not even. Probably just give it a bump in voltage and you get to 4000 without too much trouble. Underneath this Noctua air cooler, we've got a i9-9900KS, which is the really highly binned special edition version of the i9-9900K. So its stock overclock frequency is 5 gigahertz on 8 cores and 16 threads. This chip specifically runs at 5.3 gigahertz on all cores. No problem whatsoever. Just running this Noctua air cooler, no liquid cooling required. And it is delidded and direct die cooled. But the best part about it is, as you'll see when I power this guy up, the processor runs at 5.3 gigahertz on all cores, but only when it needs to. Otherwise, it turns itself down to 800 megahertz or, something absurd, and it runs on like 12 watts of power when it is just chilling. So this thing is super energy efficient, while at the same time being crazy fast, crazy powerful. Get the nice illuminated Halo NZXT fans, and then also there's addressable NeoPixels running on the roof inside the case to give the inside of the case some light. And as you can see, as fast as that, we're already fully booted up and running. That was probably, what, 10 to 15 seconds maybe? The whole point of having that old school SATA Samsung hard drive, the small one, the whole point of that is just a backup, essentially a rescue drive. If something were to happen, like if the computer got a virus, or if something happened with the Windows update or something where it just crashed and it just isn't going to start, he has that 256 gig Samsung SSD as a backup. So if something goes wrong with his main drive, he can just boot from the other drive, and then he can just image or restore whatever image backup he wants onto the main M.2 drive, and he'll be back in business that quickly. So now your main primary Windows drive is 1 terabyte, which is the M.2 drive. The storage drive is 4 terabytes, which is the 2 M.2 drives, and then this is the backup drive. I'm going to go ahead and rename that to OS Backup. And now we are on my personal home network right now, and what I'm going to do is grab a large movie file and copy it over so you guys can see just how fast the do Ready Player One. This is a 22 gig MKV movie file. We'll go over here to the storage folder. This is the RAID 0 dual M.2 hard drive. And as you can see, it's going at 1.1 gigabytes per second. So 15 seconds to copy a 22 gig file from my network server onto this hard drive. Crazy fast. Now if we take this same file, copy it, and move it from there to the other M.2 drive, the main M.2 drive that's 1 terabyte, we're going at 3.1 gigs per second. That is just dirty fast. It did tail off down to 2 gigs per second, but as you can see, that was what, 5 seconds, 6 seconds maybe to transfer 22.5 gigs. I mean, that's just ludicrously fast. Move it back over to the other hard drive again, and once again we're up to 2.7, 3.4 gigs per second. Really just silly fast. Now, let's see, I'm going to show you guys quickly. Pull up the System Information Viewer program, which shows us... What's going on with this mouse? It shows us the processor. And as you can see, right now it's running at 800 megahertz, which is crazy slow, and that's using 16.99 watts, 0.75 volts with, a package temperature of 22 or so, which is just incredibly quiet, efficient, and cool. But if we open up like MacRam or something like that, you'll see that it jumps up to 5.3 just for a second, to boost the loading speed of the program. It goes all the way up to 5.3 gigahertz just for a second, just as long as it needs to. Alright, now quickly, the last thing I wanted to do was to show you guys how the computer performs when it is under stress. It's actually doing something, so I'm going to go onto my network and just pull up a 4K video. Let's see, we'll grab one that is old. The older the better, so I know I haven't already edited it yet. We'll take this. This is a 10 gig this is probably 1080p, but it might be 4K. And copy this file over to the storage folder. It's still running at 1.1 gigs per second transfer speed over the networks, which is great. And then I'm going to open up Shotcut, which is my preferred video editing software because it is intuitive and free and has quite a bit of good solid features. Next I'm going to grab my logo because we want to put that on the video right at the beginning. Well, we're not going to, because it's going to take too long. I just want to do this quickly so you guys can see it. So we'll just grab the initial video, import it really quick, and put it down here. And then we're going to export this for YouTube. So we just click on the YouTube setting, which is great because it will set all the different specs, resolutions, aspect ratios, bitrate, all that stuff that YouTube prefers, and you don't have to deal with any of that. You just tell it you want YouTube format, and then we tell it to export file, tell it we want to save it on the main Windows drive. We're going to call it test, and we're going to save. And now it is started. Now if you look over here, This is the system information viewer panel, and it shows that the computer is now running 5.3 gigahertz on all cores all across the board, and that is using 32% of the power of the CPU. The temperatures are anywhere from 44 to 69, 73 degrees, but well within reasonable tolerances. Once you get up towards 90 degrees Celsius, you might want to consider your cooling and see if maybe you should either reapply your liquid metal or thermal paste, or maybe look into getting a different cooler. But we're still hanging out in the 44 to 72 degree range, and it is using 194 watts. The memory is running at 3.6 gigs. The integrated graphics is running at 1 gig right now, and it's using 44% of the integrated graphics power. It's a nice software panel just to give you, real-time statistics, but as you can see, this is using the using all the resources of the computer on all the different cores, and pushing it quite a bit, and the temperatures are totally right in the red where you want them to be. Everything is running nice and smooth and steady, and the file is already 22% exported with 6 minutes and 43 seconds left. So it's gonna end up having been about 9 minutes or so to do that whole export, and the file itself is a 14.5 minute long video, so about 2/3 of the length of the actual video is the time it takes to do the export or the render or the transcode or whatever you want to call it. So pretty fast, pretty efficient, and as you can see, with only 30% of the CPU's power being utilized, you can do whatever you want while that's happening. Like, I can jump on the internet, go to Gmail, check my emails, maybe go on eBay and see what's on my watch list, and it's not going to do anything to slow down your render, and computer's handling it nice, and the temperatures are still nice and low. That's probably really all we need to do as far as that goes. I'm not gonna waste any more time and electricity on this little test, but as you guys can see, let's do, and now if you notice, as soon as I shut that down, the processor speed went back down to 800 megahertz instantly, back down to 16 watts of power usage, and 3% of the CPU's power is being used again. Now we're down to 0.4%. So, like I said, super efficient CPU. I guess that's about it. So thank you guys for watching. Michael, let me know if you have any questions at all. But otherwise, she's all set, and I can pack it up and get it in the mail to you ASAP. As long as there's nothing that you don't need to add or change on here. Thank you guys for watching.